In this lesson, we're going to introduce the idea of a function, which is a real important topic in algebra. So we're going to start by understanding what a relation is. A relation is just a connection between two sets of numbers. So if we have a connection, some connection, we can show this in a couple ways. We can show it in kind of an XY table here, where we take two groups of numbers. We'll call one the x's, like 1, 2, 3, 4, and the other one the y's, and that's 5, -2, 3, 0. And we'll just say that these are connected. There's something that connects these x numbers here with these y numbers here, okay? Then sometimes we have this thing called a function. And a function is when we have each x value only goes to one specific y value. So we say we have one output for each input, or one y value for each x value, okay? So we think of a function as having an input and output. Numbers go in, these would be the inputs, the 1 goes in and a 5 comes out. 2 goes in, -2 comes out. 3 goes in, 3 comes out. Okay, so one y value for each x value. And we call these input values, these x values, we call them the domain. So the domain is a set of all input values. So all these numbers that get put into the function, that's a domain, or into the relation. Okay, relations have domains also, but mostly we're going to talk about functions. Then we have the range. Well, that's all the outputs. So the set of all output values is the range. All of these guys over here, the y values. Okay, so the domain is the x values, the range is the y values. So when we're talking about relations, we have different variables, two different variables, two different things changing. One of them is independent. It's the variable that doesn't depend on the other ones. It's the one that stands all by itself. That's the independent variable. And the dependent variable is what it sounds like. It's what depends on the other ones. That's what we call the dependent variable. All right, well, now let's try some of this out and look at some specific relations and functions. Moving on to the exploration here, we want to look at some graphs and some tables, and we want to decide if these things are functions. Okay, functions can be shown as an equation, as an input-output table, as we saw. We can describe it in words. We can describe it as a graph. We can also describe it as a set of ordered pairs. Okay, so here we have a graph. Okay, we want to explain why this shows a function. Well, remember that every x can only go to one y. That's the key. Every x can only go to one y. And so here we have 4 going to one y value. Here we have 3 going to one y value. So this represents the point 3, 2, which means when x is 3, y is 2. When x is 2, y is 4. When x is 1, y is 6. When x is 0, y is 8. Okay, so we have one specific y value for every x value, so this is a function. So every x value goes to only one y value. Now, where we would have a problem is if we had something like this. Well, if there was a dot up here, that would mean we've got 3, 2, and 3, 4. So what that means is that 3 is going to 2, and 3 is also going to 4, and that's a problem. That is not a function. So every x value can only go to one y value. Otherwise, it's not a function. So now we want to describe this in other ways. Well, we could do a table, or we could do an equation if we could think of one there. Maybe a good place to start is just to write a table. So we'll just erase out 3, 4 there. And let's make a table together, all right? So we have an x and we have a y. And let's just go through these points. We have the point x is 0, y is 8. So when x is 0, y is 8. When x is 1, y is 6. when x is 2, y is 4. Let's go separate these 2, 4. When x is 3, y is 2. When x is 4, y is, what's the y value here? Well, the y value is 0. Okay, so there's one way to describe it in a table like that. We could also list them as a set of ordered pairs, and here's how we do that. We're going to make a set, and we'll use these kind of squiggly, let me try that again. We'll use these squiggly brackets like this. These are called set brackets, and we're going to list all the ordered pairs. We've got 0, 8. Remember, the x comes first. 1, 6. And we put ordered pairs in parentheses. 2, 4. 3, 2. And 4, 0. We'll put another little set bracket over there. So there's a list of points. So 2 different ways here to describe this function. There's that one there. There's that one there. Okay? We'll get into equations and all that kind of stuff later. Now it's your turn. So we're going to go to Exploration 2 and work through these problems, and decide if it's a function or not. Remember that to be a function, every x must only go to one y value. Every x value has only one y value. If it has more than one y value, then it's not a function. So work through these on this page and on the next page, and then come back and check with the video here. All right, so hopefully you worked through those. Let's see what we got. You want to see, does every x have only one y value? 0 goes to 8, 1 goes to x, or 1 goes to 8, 2 goes to, they all go to 8. And is that okay? Yeah, that's fine. So this is a function because every x value only goes to one y value, okay? Every x goes to one y, okay? Here, is this a function? 8 goes to 0. Now 8 goes to 1. Now 8 goes to 2. Well, 8 can't make up its mind. When you put 8 into us, it's not a function. So not a function. Okay? So we see that it's not a function because 8 goes to different y values, or we say it maps to different y values. How about this thing? This is a little different one. We call this a mapping. So 1 goes to 8, 2 goes to 9, 3 goes to 10, and then 3 also goes to 11. So we have the inputs going from left to right here, and 1 and 2 are good, but 3 wants to go to 2 different places, and that's not a function because 3 maps to 2 different numbers. So if we have a number that maps or goes to different y values, that's a problem. Okay, how about here? Well, 0 goes to 8, 1 goes to 6, 2 goes, that's fine. Okay, 3 goes to 2, 4 goes to 2. It's okay that they both go to 2 as long as 3 only goes to one place. 4 goes to one place, that's all good, but look at 5. 5 goes to 4 in this dot, and 5 goes to 5. That's a problem. 6 is all good. 7 goes to a 5 there, and then 7 goes to 8. 7 can't make up its mind. 7 has 2. So this is not a function because 5 and 7 map to 2 dots. They have 2 dots above them. And how about we just say that x and equals 5 and x equals 7 fail the test of only going to one y value. How about this? Negative 2 goes to 5, negative 1 goes to 8, 0 goes to 6, 1 goes to 6, 2 goes to 7. That's a good function right there. Even though 6 repeats, that's fine. 0 goes to one place, 1 goes to one place. Every x value only goes to one y value. It passes the function test. So every x has only one y. Passes the test. All right, so how about this? Does it pass the test? Does every x value only go to one y value? Negative 2 goes to 0. Negative 1 goes to 0. Now negative 1 is going to 1. 0 goes to 1, 1 goes to 2, 2 goes to 2. Well, negative 1 can't make up its mind. if you were to graph this, we'd have -1, 0 and -1, 1. There'd be 2 points right on top of each other. So this does not pass the function test. So it fails the test because we have an x value that goes to 2 different y's. What if we have a radio frequency x in a listening area that has one radio station y? So you turn your radio station to 99.9 and it only goes to one radio station. Well, that's a good thing. That is a function, okay? Because every x goes to only one y, okay? Every x goes to one y. So it's a good thing when radio stations, every frequency only goes to one radio station, because then if we took our television station X and we found more than one channel Y, okay, so if we turn to one radio station, channel 10 on your TV station here, we turn to channel 10, and what if two TV channels were trying to show up at the same time? Well, that'd be a mess. Your TV wouldn't know what to show. And so this is not a function because we have an x with more than one y. Every x has to have one y. Well, what about this? X equals 2. Well, if x equals 2, what's y? We've got to have a y. Well, x equals 2, 2, 4. There's a point that has x equals 2. Are there other points that have x equal 2? 2, 5. 2, 6. Okay? This equation represents all of these points that have an x value of 2. So if we just have an x value of 2 and we don't determine what y is, this is not a function. We have no way of finding out what y is. So that y is not determined by x, okay, not a function. Well, how about here? If we put a number in for x, is there only one possible y value? So if we put in, for example, 1 for x, we get 2 times 1 plus 3. 2 times 1 plus 3 is 5. And that's the only thing that can come out if you put 1 in. Now, if you put 2 in, we have 2 times 2, which is 4, plus 3. We get 7 out. Okay? And we could do this all day long. Let's put maybe -1. What if we put negative numbers in there? Well, if you put a -1 in for x, we have 2 times -1, which is -2, plus 3, which is 1. So every time we put a number in here, we do the math, and we only get one number out. So this is a function. Okay? Because every x produces only one y. Put something in for x, and only one thing is going to come out. So we see on the next page here, we're going to look at just a couple ideas that we just discovered. One is we notice that whenever we have a graph, that there can only be one point in each vertical line. If we go up and down, there can only be one point, because if there were 2 points, if there was a point here, now that x value has 2 y values, and that's a problem. Okay? So every x value can only go to one y value. Here, this is a problem because this x value goes through 2 y values. So there's one there and there's one there. Okay? So every x here does not just have one y value. Some have more than one. So the vertical line test says this: a graph represents a function when no vertical line passes through more than one point. Can't pass through more than one point. Now, every vertical line doesn't have to pass through a point. See, there's some vertical lines here that don't even touch any points. That one does. Okay. But what about this vertical line? Let's see if I can get it right next to it. So that one doesn't quite hit that point. That one doesn't hit any point either. And that's okay. So they don't have to hit any points. Okay? So it's a function if each vertical line hits only one point or no points. It's not a function if it hits more than one point. So is this a function? Try the vertical line test. Can you pass that line through, you know, these different lines through here? Whoops. Okay. if we take vertical lines like this, yeah, okay, none of them go through more than 1 point, so yes, this is a function. What about this guy? Is that a function? If we try a vertical line through here, we can see that it goes through more than 1 point, so no, this is not a function. Okay, so we've talked about these functions as having inputs and outputs. So it's a good way to think of it is it's like a machine. So you put some number in the machine, something happens, and something comes out. Maybe the machine is controlled by y equals 3x. Well, if negative 2 goes into this function, it gets changed, and negative 6 comes out. Okay? So a function is like a machine, and we call that the function machine. Okay? A domain is all the numbers that could go in, and a range is all the numbers that could come out. So for this kind of function here, y equals 3x, we can put any number in. So the domain would be, for y equals 3x, the domain is all real numbers. Okay? The range is what numbers can come out of this machine? Well, anything can come out. You put in 100, you get 3 times 100. You put in 2.5, you get out 7.5. You put in a negative number, you get a negative number out. Okay? So the range is all real numbers also. Anything can come out of this. But what if we have something like this? Here's a set. Let's say here's our function. 2, 3, negative 1, 4, and 5, negative 3. Okay, there's our function. Every x is only going to one y. But in this case, the domain is the numbers 2, negative 1, and 5. And we're going to put those in order. And we put a little set brackets around that. The range is all the y values. What are the y values? Well, we have 3, 4, and negative 3. Negative 3, 3, and 4. And the range. So there's only 3 numbers that are inputs. There's only 3 numbers that are outputs. Okay? So this is kind of a limited function. And so the domain is a small set and the range is a small set. So that's the key features of a function. For every x, there's only one y. It's got to pass a vertical line test. And it's got to have, for every domain, there's only one range coming out of it. So go on to the next page here and try some of these out. And just keep in mind that we got to obey the rule of function. For every x, there's one and only one y.